Yeah, my name is Ayush Lal and I am a PCM fellow. So today we are going to see two questions which are totally based on these three subjects. Okay, so let's pick our first question. We have this one. What does this question say? So there is a particle which starts from rest, means u is equals to 0. Now moves in a straight line such that its displacement at time t follows an AP. Okay, means for the first second, I can say what it is traveling how much A1. For the second, it is traveling what A2. Next, for the third second, it is traveling what A3. Then next, from here, what we all can see. Let's see. The sum of these distances is equals to the number of valence electron in a single molecule of ClF3. Means A1 plus A2 plus A3 is basically how much? Sir, valence electrons in ClF3. So let's see. So sir, Cl, next alone pair, next alone pair, next F, F and F. You all can see that, sir, this is sp3d, means a T-shaped structure, a T-shaped structure. And what else we can have? So they are talking about valence electrons. So what is a valence electron? All valence electron are those electrons which are present in the outermost shell. So you all know that F and Cl both are present in the 17th group, means they have 7 valence electron, means 4 into 7 means 28. So A1, A2, A3 their sum is equals to 28. Now these three ones are in AP, so we always know that if three are in AP, we always take. Let's take a minus x, a and a plus x. Yes. Next. From here, I can write what? Sir, 3a is 28. Next. We have seen this all. Next, what it is saying? So the number of lone pair on the central atom of ClF3 is D. So all of you can see the central atom is this one only. Yes. So how many lone pairs it is having? So lone pairs they are having are 2. Then next, basically 2 is D. So if D is 2, where D is used? D is used here. Means we have to find instant velocity at t equals to 2 seconds. Next, what else we can have? So sir, the common difference of the AP is equals to the acceleration of the particle. So let's see one by one what they are telling. So basically, we are entering in 1D. So in 1D, we have three equations. Here we need to use S is equals to UT plus half AT square. Why we need to use this one? Why we need to use only this one? Because we have distance, we have U, we have T. That's why we should use this. Next, let's try to use for T equals to 1. S1 is basically A1 only, and A1 is how much? Sir, U we know is 0 into 1 plus half A into 1 square. Next, for T equals to 2, S2 is how much? S2 will be A1 plus A2. Why? Distance traveled in 2 seconds. So it is traveling A1 and A2 both. Next, 0 into 1 plus half A into 2 square. Next, you can write what? S2 minus S1. It is this one is equals to how much? You all can write 3 by 2A. And this is how much? Basically A2, and A2 is basically A. So from here we can write A also as 3 by 2A. Next. So we know that 3A is how much? 28. So 3 into 3 by 2A is how much? 28. Means A is how much? 56 by 9. Then if you have got acceleration is 56 by 9. means acceleration is equals to 56 by 9 meter per second square. So what is instantaneous velocity? So they are saying for t equals to 2, we have to find instantaneous velocity. Yes, instant velocity. Yes. So what should we use? So we can write it here as v equals to u plus at. Yes. Why? We have differentiated the previous equation to get this one, or we know that this equation is used for instantaneous velocity. So how much? V is equals to we know at u we know as 0 and a. Here we should have capital A. So here how much? At, how much? A, 56 by 9 into 2 means 112 by 9 meter per second. So all of you can see which option? Option number 2 all. Then next. After seeing this question, let's pick another one. They are saying what? There is an octahedral complex. So octahedral complex, you all can see. So in octahedral complex, we have seen what? They all are perpendicular to each other. They all are perpendicular to each other. Means here, 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 this one, this one, this one, and this one. They are perpendicular to each other. Next, we know what? Sir, M is the central metal atom at origin 0, comma 0, comma 0. So let's put M. So sir, M is somewhat here. M is somewhat here. Next, 0, comma 0, comma 0. They are saying what? The ligands X and Y are placed at a distance d from the origin along X, Y, and Z axes. Okay. Next, mass of X given as 80 AMU, mass of Y is given as 20 AMU, and mass of central atom is negligible. Then next, N1 is the number of geometrical isomers for this one. Okay. So what we can take? So let's see geometrical isomers of this one. So M is there. We have what? Let's talk first for cis. For cis, we can say that they are present at 90 degree. Yes. So here how much x? Here how much x? Next, anywhere we can take y. Anywhere we can take y. Yes. So like this type of structure we can have. Like this type of structure we can have. Now, if you try to move x to any other point, if you try to move to x to any other point, you will get same to same structure once they are symmetric. Means only one possibility. Let's see for trans. For trans, put x above and then put x below and then write all the y's. Here only you can see only one possible. There is no other structure. Done. Means N1 is basically 2. Yes. Next. Let's see what. Let N2 be the number of Y ligands located in XY plane in the trans isomer and X ligands are on the Z axis. So let's see. So I have taken what? So there is a Z axis. Let's see that. This is Z axis. This is X axis and this is Y axis. So basically X ligands are here. M is at the center. So basically we know that they are perpendicular. They are perpendicular. So basically where is Y? Y is present on XY coordinates. Yes. On XY planes. Yes. Meaning there are 4 of Y's which are present in XY plane. So N2 is how much? 4. Let's talk about now what they are saying. Let R be the ratio of momentum of inertia about Z for the cis where X at D00 and 0D0. So let's see. So here we are going to have what? Here we are going to have what? So there are two x present in the here, and here 0 d00 and 0d0. Next, where is y? Sir, y is here, y is here, y is here, and y is here. Now this one we know this is z-axis. Yes, this one we know this is z-axis. Next, I can say that moment of inertia of cis is equals to, let's talk about first of the z-axis ligands. So there are two of them into m of y into 0 square. Sir, why we have done this? Inertia is basically calculated by m into d square, and d is basically the distance from the axis. So can you see the distance is 0? Next, plus I can write what? 2 times into mx into d square. Yes, why? All of them are present at a distance of d only. Yes, next, plus 2 times my into d square. So from here you get what? Isis is equals to 2 times mx plus my into d square. Now you know mx is how much? Mx, you all know how much? Sir, mx is 80, my is 20. So 80 plus 20, 100. So it is going to be how much? Sir, 200 d square. And let's calculate what? I trans, what they are saying. So sir, here they are saying that both the x are present on the z-axis. Yes. So z-axis. Next, here is x and here is x. So we don't need to worry about x. We can directly write, so 2 into m of x into 0 square. Next, you can say that sir, y are present here. So y and y. So how much? Plus 4 my into d square. How much? I of trans is equals to 4 into 20 into d square, means 80 d square. Then, so R is how much? The ratio of moment of inertia of cis by moment of inertia of trans. That is what? So 200 d square by 80 d square. Yes. So this is going to be 2.5. Next, if you have seen that this is 2.5, what is the value of n1 plus n2 into r? So sir, this one we have seen 2, this one we have seen 4, and this one we have seen 2.5. So 6 into 2.5, 15, means which option? Third. So like this, we can do different types of questions. Okay. So let's end it here only. Bye all.